Welcome to our educational channel. From class 8th mathematics, the chapter 6 is sets. So in this sets chapter, let us see these are the following topics one by one. First, let us see what is the set and definition and how to representation of the set. That means the type of sets will be different and representation of the set is one. And how many types of the sets are there in this? Main subset and proper subsets, universal and complement of set. So those definitions with the numerical sums you'll see, and set operations like union, intersection, those including difference, and followed by the Venn diagram. So these are the topics I'll explain you briefly from this sets chapter. First, let us see the how to define the set. So which is studied in the previous class also. The main thing, a set is a collection of well-defined objects. So simple word, collection of well-defined. So the word we need to understand here. So what is well-defined? So well-defined objects. Now if you take one example, so collection of the tall students in the classroom. So there is not a set. So it's not well-defined. Tall means you can't say which number to which centimeters is the tall. Or else if you take the number of students whose weight is between 135 centimeters to 140 centimeters. So this is the defined properly. So if any set, that means there's some group of elements, if we can collect with the proper definition. So this command as set. That's why a set is a collection of elements with well-defined objects. That means objects is called elements in this. And the word elements we can use to denote the numbers or variables in the set. For example, A is a set having elements 1, 2, 3, 4. So in this 5 is not there in this set, only 1, 2, 3, 4. 6 is not there. So if it's not there or there, we can use these two symbols. So this if you keep the cross, this not. This is the belongs to. For belongs to we can use this symbol. This for not belongs to. That means in set A, for example, 1 is belongs to set A. So 1 is in set A. And 6 is does not belongs to set A. To use the words, either the particular element is there in the set or not, we can use this belongs to word. Okay, these are the main things. Now let us see how to make the representation of the set and what type of the sets. And in this representation also you have two types and converting from one form to other form. Those will let us see now. Representation of a set. So to denote or to represent particular set, the mainly we have two ways to represent the set. So those two ways I'll explain briefly. And before that, any set in general, a set is represented by the capital letters of English alphabet. Like if you take A is a set. It's having elements 1, 2, 3, small a, small b. Within the curly braces, these brackets only we can use. So this 1, 2, 3, a, b are the elements in set A. Okay, this is the format of the set A. And two ways we can represent, right? So one is the roster form. Roster form, or we can call it as a tabular form. Both roster form or tabular form. This is the one way we can represent. So let me show you one by one. And second way to represent is the set builder form. Roster form and set builder form. Set builder form, or we can call it as a rule method. So this is the tabular form, and only to represent the way of representation we can use. So roster form we can represent within the bracket the elements with exactly with commas. Just in the form, elements of the set are enclosed by curly braces after separating them by comma. That means set A is having elements A, B, C, D, E, or set B we can represent the elements 1, 2, 3, 4, 5 and so on. Even for example set C having elements 0, 1, 2, 3 so on till infinity. So only the elements by using within the curly braces, the elements used with comma, this is the roster format. So roster form. Now when you come to this set builder form, so this is actually rule method. So given roster form, we have to make into set builder form. Now 0, 1, 2, 3 so on, right? So we could not write all the terms in this. So actual elements of the set are written, actually elements is not written directly. So but based on the elements we can make the statement. So for example set A is having x, means all the elements in set A I am representing with x, that is x belongs to natural number and x is less than 7. The meaning is no need of writing all the natural numbers from 1 to 6 because x is less than 7. Instead of writing 1, 2, 3, 4, 5, 6, we can represent this. For example, set B. If you want to write whole numbers from 1 to 100, so 1, 0, comma, 1, comma, 2, comma, instead of writing, we can use the formula method, like a rule method. So your rule is x such that x belongs to whole number and x is less than 101, right? So this the meaning is all the elements from 0, 1, 2, 3, 4 so on till 100 whole number. Instead of writing all the elements using comma, we can represent that numbers by using some rule or some statement or formula. So we can use instead of writing the elements with comma. So this is the set builder form. Now let us see the converting. If any question is given in roster form, how to convert that into set builder form. When the question is given in set builder format and how to convert into roster form. Let us see with examples. First let us convert following into the tabular form or this roster form. Now one question is given x such that x is equals to 2n by n plus 2, comma, n belongs to whole numbers and n value is less than 3, right? So this is one set. Let's take set A. Now this is in set builder form, right? So we have to convert into roster form. If you see the condition that n values belongs to whole numbers but n value is only less than 3. So we have, that means n is equals to 0, 1, 2. Only 0, 1, 2. First you have to substitute in the place of n 0. So here if you use x is equals to, so 2 into 0 by 0 plus 2. 2 into 0. So 0 by something is 0. Again x. 2n by n plus 2. But next n is 1. So 2 into 1 by 1 plus 2. 2 by 3 it is. Again x is equals to, so 2 into 2 by 2 plus 2. So 4 by 4, that is 1. We got 0, 2 by 3 and 1. Now this we can represent in the set roster form. That is A 0, comma 2 by 3, comma 1. This is in formula method or statement we are making into roster form. Just only simplify the values. And anything is given in this way you can do it. Let's take one more example. Let's set B is having x such that x belongs to whole number and here is condition is 8x plus 5 is less than 23. According to this, 8x plus 5 is less than 23. So to convert this into tabular form, just in the place of x, what value if we keep? So whole numbers means only from 0, 1, 2, 3 so on, right? So let us take x is equal to 0. If x is 0, you can use roughly 8 into 0, 5. So 5 is less than 23. So 0 is exist. That means set B, 0 is possible. Next, after x 0 then 1. So 8 into 1, 8 plus 5, that is 13 is less than 23. So 1 is also. Again when x is equals to 0, 1, 2, 3, so on, right? Next to 2, if we keep 8 into 2, 16 plus 5. So 21 less than 23. Yes, 2 is exist. When x is equal to 3, so 8 into 3, 24 plus 5, but 29. Less than 23 is wrong. So it's not more than that. Only 0, 1, 2. So this is in set builder form, it's a roster form. Same way when it's in a tabular form or roster form, how to convert into set builder. Those example. For example, question set A is given 0, 3, 6, 9, 12, 15, 18. If any question is given in roster form, first observe the numbers. What relation is based on this? These all are, if you notice, all are 3 multiples. 3 multiples, 3 into some natural number getting this. 3 into 0 is this. 3 into 1, 3 into 2, 3 into 3. So 3 into some number. So x such that x is equals to 3n. So 3 into one number, if you multiply, you are getting this. But n is from where to where here. So here is n belongs to whole numbers, because when you keep in the place of n 0, first you are getting. In the place of n 1, 3 into 1, 3. 3 into 2, 6. So until 18. So 3, 6 is 18. So n value must be less than or equal to 6. 6 also included. Okay, so this is in set builder form. So given number, you need to understand clearly what relation between the numbers. That relation you can exist in the this set builder form. This relation. Okay, this is in this way. So any series is given or any terms with commas are given. That relation you observe first, and that we can convert into the set builder form. Types of sets. So in this set, what are the types are there and how to use those sets in the problems? So let me explain one by one. First, let us see the types in this. First one, the finite set. Most of the sets in the word itself, we can find the meaning. So finite set. According to this, a set with finite number of elements in it is called finite set. So some fixed number. So let's take a set A is having elements only 3, 4, 5, 6. That's all. So this is a finite set, not infinite. Infinite is the next one. And let's take set B is having elements 4, 5, 6, even so on till 1000. This also is a finite because the last number is 1000, some fixed number. Here is one more word, the cardinal number of set. Cardinal means the number of elements in the set, n of A. Number of elements in set A is 1, 2, 3, 4. Right? So cardinal number. So n of B. How many elements in set B? Total 1000, 1, 2, 3 is missed. So 997. Right? This is the cardinal number of a set. And that's only for the finite set we can find out. And second one, the infinite set. Infinite. So it's exactly reverse of the finite, no, opposite of the finite. A set which is not finite is called the infinite set, which is not finite. That means let us take set A. So it's x belongs to whole number. So some infinite set we can take. So x is belongs to whole number, but x is greater than 3. So 4, 5, 6, so on. So it's an infinite set. X is greater than, x is less than 3. Okay, oh, sorry, not x is greater than 3 we should take. Greater than 3 means 4, 5, 6, so on. So till infinity. So any set is not finite, it will come under infinite. Okay, that is the definition in this. And there is no cardinal number because infinite it is, right? And next, singleton. So third one is singleton set or unit set. Singleton or unit, that means only one element in any set is having single element is called a singleton set. Let us take one example. A is one set having only element 2. This also a singleton set. Or set of whole numbers between 6 and 8. Whole numbers between 6 and 8 is only 7. So singleton set. And even prime number. So 2. There's only singleton. That means a set which is having only one element in it is called singleton or unit set. Next, fourth one is empty or null. Empty or null set. A set having no elements. Now set A is just only empty braces you can write. So set having no element at all in this. That means the set which has no element in it is called empty or null set. Okay, this we can use the symbol, keep the circle and keep the line. So we can use as a pi or null set it is. Okay, and let us see one example also. X such that x belongs to natural number and x is less than 1. So this is the set B. This is also null set. X is natural number and x is less than 1, there is no any element. Okay, this is so on. These are the empty or null set. And next one, joint or overlapping set. Joint or overlapping. So when you come to this joint or overlapping set, the two sets are said to be joint or overlapping sets if they have at least one element in the common. So should take two examples in this, set A and set B. Let us take these two sets, set A and set B. So set A having 5, 7, 9. Set B is having 7, 11, 19. So these two sets is a common element. At least one should be common. 7 and 7. Even not only one, more also no problem. Just only having must be one element as a common. So at least one element should be common in the both the sets. Then we can call them as joint or overlapping sets. And same way, joint to opposite is disjoint, right? So we can see the word and meaning of this. Disjoint. Disjoint set means if two sets having no common element. That is set A is 1, 2, 3 and let's take set B 4, 5, 6. So no common, no single element is the common. So the two sets are said to be disjoint if they have no common, no element in common. If there is no any element in the common, these are disjoint sets. Right? Again, next we have equivalent set. Let us take the word equivalent. Equivalent. And this is one, and one more is eighth one is equal. I'll tell this both together. Equal sets. Equivalent and equal. So two sets are said to be equivalent if they contain the same number of elements. Same number of elements. Elements should be same or that is different. So for example, set A is having elements A, B, C and set B is having elements X, Y, Z. Same number of elements. Same number of elements means equivalent sets. So is A is equivalent to the B. Okay, same number of elements. So that means cardinal number is same. That is here n of A is equals to n of B. This is for the equivalent sets. And when you come to the equal sets, you should having same elements. So set A is having A, B, C and set B is having B, C, A. So this A and B are equal sets. Same number of elements and same elements also. So the two sets are equal if both sets have the same elements. So same identical, same values. It should be, right? Then we can say it is A is equals to B. So number of elements and elements also must be same. There's equal sets. Only number of elements are same. There's a equivalent sets. Okay, these are the things, and that means you can one thing you can conclude here. In equivalent sets, the number of elements are equal, whereas in equal sets, the elements are the same. So every equal sets are always equivalent. That means equal sets. These are always equivalent sets. But whereas equivalent sets not necessary to equal always. Right? Okay, so these are the types of sets. And next, some more types like subset proper sets, universal complement sets. Those also let's discuss. Subset and proper subset. First, let us see about the subset, then we'll discuss about the proper subset. When you come to the subset, in the word we can get some meaning. If all the elements of set A, let us take some set A and B, A and B. So set A is having elements and set B is having the elements. According to this definition, if all the elements of set A belongs to set B, then the A is said to be the subset of B. For example, A is having elements 5, 6, 7 and B is having elements 2, 3, 4, 5, 6, 7. So every element here 5, 6, 7, these three elements are in set B. That means set A is a subset of set B. So we can use the word AB in between the symbol we should write like this. So this U symbol cross now. This is a subset of symbol. A subset of B. All the elements of set A belong to the set B. Then set A is said to be the subset of set B. Right? Same way you can take any other examples. Like X, Y. Let us take X is a set having A, B, C. Even set Y is having also elements A, B, C and D. Only one is extra. Even every element in set X or belongs to element set Y. So X is subset of Y. Right? This we can use for subset. And the symbol is this. Subset symbol you can use in this way. And when you come to this proper subset, so to get the proper subset we have one more definition. Subset and proper subset. Small change you can see in this. So proper subset. Here the set A is said to be proper subset of B if first case all the elements of A are contained in set B. Like let me take example. A is having elements same like previous now 5, 6, 7 and B is having elements 3, 5, 6, 7 and 8. Yes. So here, so there exists at least one element in B which is not in A. So in B some must be one extra which is not in A. Now instead of previous example, if you see ABC and Y also in case only ABC, even though X is a subset of Y, same time Y is a subset of X. But to get the proper subset, every element in A, the elements of set A are contained in set B. Each and every element in A, it must be an element in B. And there exists at least one element in B which is not in A. So here is extra 3 is there which is not in A. That means A is a proper subset. Only the symbol you can use. Subset you can use this one more line down. Only proper subset is this. That means every subset we can consider as a proper subset. So proper subset means at least one extra element in set B. So the main difference, so every set is a subset of itself. Every set is a subset of itself, but it's not proper subset because there should be one extra element. That's why let us see how to find the subsets from this. Now let us take one set A is having elements 1, 2, 3. Now total n of A, number of elements in A is 3. Then number of subsets is 2 to the power n. So 2 power 3. 8 subsets we can make using this only 1, 2, 3. That is only 1 is having one element is a subset and 2, 3 we can take. Next 1 comma 2, again 2 comma 3, 1 comma 3. Null set, if there is no any element, is also subset. Again itself 1 2 3. Every set is a subset of itself. That's why 2 power n is the number of subsets. When you come to number of proper subsets, this itself is not there. That's why 2 to the power n minus 1, one number less. So number of subsets is 2 power n. Number of proper subsets of it is 2 to the power n minus 1. Okay, no set is proper subset of itself, but every set is a subset of itself. Okay, this is only the change you can notice in this. Universal set and complement of set. Let us see these both differences separately. When you come to this universal set, it is a set which contains all the sets under the consideration of its subsets. A universal set is denoted by symbol or U. Okay, these are the two symbols we can use for to denote the universal set. Let me show you clearly. For example, set A is having elements 1, 2, 3, and set B is having elements 4, 5, 6. Set C having elements like 7, 8, 9. Now if you come by using this ABC, for this we can take it as a universal set. So these all sets must be subsets of this universal set. So you can take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a universal set for this ABC. Okay. So that means set which contain all the sets under consideration as its subset, and a universal set is denoted by in this type. Okay, these all the sets are subsets of this universal set. And complement of set. So the simple thing is universal is all the sets contained in one. And next to complement of set. Let us take one example. Let us take first universal set is with U, is having elements 1, 2, 3, 4, 5, 6. Let us take this is a universal set. And if we take set A must be subset for this. So only like 1, 2, 3. Then complement of set A. So we can use complement of set A with A dash. Complement of set A is the elements which is not in A. So remaining all from universal set. 1, 2, 3 is there. So remaining is only 4, 5, 6. That means the complement of a set A is a set of all the elements in the universal set which are not in the set A. Complement means except the elements in set A, remaining elements should be in the complement of set. Like, okay, set A. Let us take one more example. So is a universal set is x belongs to natural number. Let us take set A is x is equals to all the even numbers. Then A complement. So complement of set A, it must be odd number. So x is equals to only odd because even numbers are there. From the natural numbers, if we remove the even numbers, remaining are odd numbers. Okay, so in this way we can represent the complement. And when you come to the universal set, all the sets which are given are subsets for the universal set. Next we'll see the set operations. Set operations. So we have two important set operations, and including that the difference also I'll explain. So when you come to the first one, union of two sets. So let us see the meaning or this word meaning in this sets. Union. The union of two sets A and B consists of all the elements which belongs to either to set A or set B or both. Let us take example. Now set A is having elements 1, 2, 3, 4, right? And set B is having elements 3, 4, 5, 6. Now when you come to this A union B, this is the, you can use this U symbol. A union B. To denote this union, we can use this. The A union B is nothing but set A and set B elements combined we should write without repeating. That means 1, 2, 3, 4. 3, 4 is there, don't write again. 5 and 6. So union of two sets A and B consists of all the elements which belong to either to set A or set B or the both the sets. Okay, this is the union of two sets. Next, so second one, intersection. Intersection of two sets. In this union is we will write all together, and when you come to this intersection, only the common, let us take set A is having elements 2, 3, 4, 6, right? And B is a set 4, 6, 9, 10. This is one example. Now A intersection is reverse, like this is a symbol. You know, if you reverse, if you take, this is the symbol. This is for to use A intersection B. A intersection B is the common elements which are in A and B both. So only the common elements. 2 is here, but there is no any 2. Should not write. 3. There is no 3 in set B. Only 4 and 6. 4, 6, 4, 6. 4, comma 6 are in elements from A intersection B. Right? The intersection of two sets A and B in the set of elements which are common to the both the sets A and B. A and B both sets which are the common, that we should write as a intersection of two sets. Right? These are the set operations, union and intersection. And in the same we have difference. Let us see one more. Difference of two sets. Let's see this also. Let us take third one. Difference of two sets. Now set A is having elements 2, 3, 4, 5, 6, right? And set B is having elements 4, 5, 7, 10. Let us take. Now when you see the A minus B, that is difference. So it's not like normal subtraction. A minus B, that means the elements which are from the elements in A which are belongs to B should be removed. A minus B means from A the elements which are in belongs to B should be removed. Okay, let me explain clearly. Now set A and this is set B. Okay, here is 2, 3, 4, 5, 6, 4, 5, 7, 10. Let us see the common. So in 4 is here, 4 is this, 5 and 5. So only 4 and 5 which are the elements belongs to B, those should be removed. Then remaining elements is only 2, 3, 6. Don't write this 7 and 10. Only A minus B is from A, from set A. The elements which are belongs to B we are removing. That's A minus B. Similarly, A minus B and B minus A are not same. If you want to take B minus A from set B, which are belongs to A, it should be removed. Right? If A and B are the two given sets, then difference of this A minus B we can make. Now let us take this B minus A. So B set should be right first, followed by A set. Okay, B is having 4, 5, 7, 10, right? Previous example. A is 2, 3, 4, 5, 6. In the both the cases only 4 and 5. 4, 5 only common, but we should write the remaining only from the starting, from only B. Only 7, 10. Right? A minus B means from set A, the elements which are belongs to B only are removing. Only 4 and 5 are belongs to B set. So are removed. So remaining. So B minus A is this. Okay, so this is the difference of two sets. Now let us see the Venn diagram, the problems based on that. Venn diagram. So this Venn diagram is the most commonly used for pictorial representation of the sets. To use with diagram wise, to represent the sets with diagram based. So we can use this Venn diagram. So the idea was given by the first developed by John Venn. So on his name we can use this Venn diagram, right? So when you come to this pictorial representation of these sets, one by one, let me show you. If you take one rectangular shape, in case this is the rectangular, it's a rectangle, take it as a U. So think it's a universal set. Inside set A and set B, having two sets. Let's take this is A and B. So A having only 1, 2, 3, set B is having 5, 7, and somewhere is 8 is outside. This is from universal set. 1, 2, 3, 5, 7, 8 are the elements from universal set. 1, 2, 3 from set A and 5, 7 from set B. That means A and B are the disjoint sets because there is no any common. So disjoint sets it is. To represent the disjoint set, we can use in this way. And instead of that, if you want to join sets, two sets are joined. That means there should be some common elements. If any element is common, we can join the sets in this type. Okay, which is the common? No, in this common place. Like 1, 2, 3, 5, 7, like A and B. Universal set is this. That means set A is having 1, 2, 3. Set B is 3, 5, 7. And 3 is the common. So common element should be in this. This for the joint or disjoint sets we can represent. And subsets. So set A is this. And inside there's one more set B. Every element in set B is belongs to set A. So we can take it as B is subset of A. And in set B, if you take the set A, then that is A is the subset of B. Okay. And let us see the shaded like union intersection also in this Venn diagram. So this is the rectangle. For universal set we can represent this type. Union, intersection and difference. 3 I'll show, 4 I'll show here. Difference also 2 cases. Let me take the 4 rectangles. Union, intersection, difference, right? Previous we discussed the in problems. Now here is set A and it is set B. Set A, set B, set A and set B. Venn diagram to represent. Let us take this the AB, same AB and AB, AB. First one, A union B. So A and B, all the elements. So we should shade everything. So this representation is A union B. A and B, all the elements together. And A intersection B, only common. So this is only the common element. So this is the shade. So this is the shaded part. Now we can take this. So represent this shaded part is A union B. This is A intersection B. Next A minus B. So A minus B is from A. B should be removed. That means only this remaining. Okay, this shaded part is A minus B. Same way here is B minus A. From the set B, if you remove this A, only this. Not even common. Okay, this is the shaded region is B minus A. In this diagram, shaded region is A minus B. In this way, you can represent the Venn diagram based on the shaded union, intersection, those and all. And only the common is here. Let me take one question, how the questions will come based on this Venn diagram and problem. Let us discuss. Okay, so given universal set is given X such that X belongs to natural number 12 less than or equal to X less than 20, and set A is X such that X is divisible by 3. X is divisible by 3 and set B is equals to 12, 14, 15 and 16. Now draw the Venn diagram to show the relation between the given two sets. Between A and B, what is the relation you have to show using this Venn diagram? Now when you come to this solution, here is a set A. X is divisible by 3. But A and B should take only from universal set. So universal set is from 12 to 20. Not even 20, 19. 12 to 19. So between 12 to 19, divisible by 3 is 12. Again 15, 18. That's all. This is only from set A. B is given already 12, 14, 15 and 16. Now this data to represent on the using this Venn diagram. Take this rectangle. This is universal set, right? All the elements. So inside we have set A and set B is a common. Let us take this A and B. First 12, 15, 18, 12, 14, 15, 16. So 12 and 15 are the common. You should write 12, 15 is here. 12, 15, no, remaining is 18. In set B, 12, 15, next to 14 and 16. 14 and 16 are here. This so A and B are fixed. But when you come to universal set, 12 to till 19. So 12 is there. And there's no 13. So in the universal set is full box. And 13, 17 is missed and 19 is missed. Those you can represent in the remaining place. Don't write within the A and B. So based on this, A intersection B is 12, 15. A union B is 12, 14, 15, 16, 18. So based on this, you can write A minus B, A union B, A intersection B, all the points in case they asked in the question. So A minus B if they asked. From A, if you remove this B, only 18. And B minus A is 14 and 16. 14, 16. And A union B is altogether in the A and B. That is 12, 15, 14, 16, 18. And A intersection B is only 12 and 15. So any question is given, using this Venn diagram, easily we can represent, right? So these are the main concepts based on the Venn diagram. Mostly you can see in your syllabus, like union, intersection and differences. Those you can expect some questions. And based on that, you can ask the word problems, even this numerical sums, right? So those are watching the first time our channel, you can subscribe to it, and to understand the concepts clearly, just follow in order one by one.